Why don't you just encode the embeddings in W0?
Okay.
Yeah, and then, so if you have more layers, the layer before the source class will become your embedding.
Right. So the filters in your convolution are your embeddings.
In the first instance, yes.
Yeah. The channels, yeah.
Okay. Other comments? Okay, fairly simple structure. Let's look at some, cross-entropy loss function. Oh yeah, interesting thing here. So not every document has to be labeled, and their loss function is defined only over the labeled documents. Okay? If you have partly labeled documents, it will still work. Okay? So the DFIDF, the TMI. Okay. You see they compared with quite a few methods. LSTMs are more traditional for classifying text. There was some work done by using CNNs. PVDBAO, PVDM, those are the work-to-work papers, methods from Wikiloc I mentioned earlier. There are a few more advanced ones. There are a few graph CNN methods. I think there are 3 of them. So they're using different filters. So Fourier filter, spline filter, and spline is a Chebyshev. I think we talked about the Chebyshev filter paper. We talked about this one. Yeah. So the other 2 are just different filters. Okay? Right. And they use several data sets, medical abstracts, this is the abstract, movie review, survey data set from Reuters, different data sets. Okay? And they are different also in number of documents and words. So for example, one of them is quite a bit bigger, more documents, but none of them is in terms of hundreds, thousands, or millions. Okay, those are still thousands, 10,000s. Number of words, again, not too many. I'm saying this because I'm not sure how this method will work if you have a million nodes. Okay, may be a problem there. And then they have an extensive list. The results are in bold, except in one case. So this is the interesting case. Okay, although all the results are quite similar here, but the CNN is doing slightly better because, so they argue because this MR data set, which is this one, the movie review, because they say the sentences are longer and somehow it works better here. Yeah. But in all other cases, their method outperforms, which is, I guess, nice. And outperforms quite significantly. There are a few more interesting experiments. For example, here, when they change the size of labeled data, they're arguing even if you use a very small part of your labeled data, up to 10%, I think, no, 1%, 20% in some cases, you still get very high results. So they're arguing that this method is very robust to missing labels. Right? So you could use it as a semi-supervised algorithm.
And this is for a small number of classes, isn't it? You know, 8 classes.
Yeah.
This is one with 20.
Yeah, the 20 is allowed. 50.
Oh, 50.
52, okay.
But this 50 classes with not too many documents.
Yeah, okay.
Yeah. Yeah.
What happens if I have a new document I want to predict?
Excellent question. So they discussed that. That's a problem because you have to retrain the whole thing again. That's a problem with also Doc2Vec. That's a problem we have. Everyone is trying to solve that problem.
Is it possible to, because you have this convolution part, right? And convolution could expect should also work with a shifted just, even though if that part has never been seen, so it might be able to just push it in there somehow.
Well, they talk about as a future work. They mentioned working on building, modifying this to not require training. I don't know how. So
Because so far you have one activation for each document, right? So that makes it document specific, your whole network.
right, if you have a new document, you can't.
Will you, with a new document, don't you change the adjacency rules?
Change.
Yeah, but when you want to introduce a new document.
Well, yes, because document
Yes.
would contain some new words, so you would have to.
So you have to start again.
Yes.
But what you might be able to do is you can because you have these words, right? You can marginalize over them. You can basically use something like a k-nearest neighbors maybe. So you can say, okay, this document is closest to these documents, so you take maybe an average of their activations, and maybe that would be able to.
Yeah, but so what they argue is that this works very well because it is able to take into account contributions in a very distant document.
Yeah.
It can't take, it's like what you said, it's like a wheel, so a document is connected to a word, which is connected to another document, which is connected to another word. So one of the arguments in the discussion is that this works well because it is able to capture a very far connection.
But they have only one hidden layer. They can't
Exactly,
go too
yeah.
far. They can go only by one.
Yeah, but you have the PMI as well. So the PMI is giving you how words are correlated in the whole corpus. So that part is capturing relationships between words in the whole thing.
But in
Same with
yeah.
TF-IDF, it's capturing like whole corpus contributions of words.
But in principle, this is like a dense network where each document is to some extent close to each other, right? Because there's at most like one word distance between them.
I think the document connections will be relatively sparse. I'm just wondering how sparse the connections between words would be, because if there only has to be one co-occurrence, I assume, for that link to be created. So,
Well, it depends how. That's one of the arguments they do about experiments, depending how big the document is.
Yeah.
If it's a short document, it would have very few connections, right? And then if it's a long document, it would have more connections, so it would affect the performance.
yes, but you'd have that connectivity defined by the universal set of all documents.
Yeah,
So
but
all
they also chop the PMI. They only take PMIs larger than 0.
Oh, do they?
So if the words, if that happens, if they only appear together once or twice, that's going to be negative, and then they assume there's no connection between the words. So they have to be very correlated for that for there to be an edge.
So, say we have two documents that are very similar to each other. You would expect that activations to be also very similar, right? At least after the first.
Maybe. I guess.
Yeah, it must be, right?
Should be.
Because the classifiers only at the very end sees the same for all of them.
They don't really talk about much about the activations of the embeddings, but
Yeah.
it should be. The embeddings appear as a result of training for classification.
You have to remember that if they're training this with a class-based model,
Yeah.
the embeddings aren't proper embeddings. They're only proxies that serve as one-hot filters that could that are targeted by labels. It's not unsupervised, so
Yes.
it's I don't know.
Like a topic.
So they actually, what they put in the images down there, the TSNE images, is that the document embeddings work very well, so you get a very good separation of similar documents. But the word embeddings are, so underneath you see they have the word embeddings. No, underneath, further down.